Welcome everybody to a new periodic podcast by the Global Warming Policy Foundation, where we have no dogma, no preconceptions, no limits to our critical thinking, and we'll discuss anything and everything to do with science, and we'll emphasize skepticism and critical thinking. So don't think you can get anything over on us, because we are going to the heart of the debate and we are going to critically analyze what's in the scientific journals, what's in the media, what people say, even what people tweet. So we're going to have an informal, unstructured discussion about this. And I have with me Dr. Benny Peiser, Director of the Global Warming Policy Foundation. Hello, Benny.
Hi, David.
Now, we thought we'd first start off with an editorial in the Nature journal Climate Change. Now, Nature Climate Change is a very interesting journal. It's an important journal, which, of course, we all read every time it comes out. But sometimes when I read it, I think that it's a bit off the boil. It's a bit showing where it's coming from, which journals shouldn't do. Journals should present the argument and the evidence. And if there is a policy thing that comes out of it, yes, they can talk about that. But sometimes Nature Climate Change's editorials don't quite do that. They go beyond that and they start taking shortcuts. They start saying things which aren't strictly true. And there were two which we'll talk about in this podcast. And the first one was called Looking Back, Looking Forward. And it was talking about climate change models, how they're 50 years old. And there's been a lot about this in the press and in the media recently, because people have been saying that the models 50 years ago did a remarkably good job at predicting what we've got today. Now, I don't know about you, but I don't quite believe that. I think you have to have a broad brush approach to what they predicted to say that they were good enough 50 years ago to say what's happening today.
Yeah. Well, this comes with a big trick, because the model that the media is referring to, that was published in 1967 by Manabe and Weatherold, actually was one of the first papers that estimated how much warming we would expect if you double CO2. And they came to the conclusion, and I quote from that paper, according to our estimate, a doubling of CO2 content in the atmosphere has the effect of raising the temperature of the atmosphere, whose relative humidity is fixed by about 2 degrees Celsius. Now, guess what? That is what the critics have been saying all along, that the models are far too hot because the models predict warming of 3, 4, 5 degrees. And what we've actually seen in the last 50 years is a much slower rate of warming. So the people called lukewarmers, who've always been criticizing the alarmists for looking at the kind of accelerated warming, have always looked at what the rate of warming has been over the last 50, 70 years. And it has been much, much lower than most of the modern models estimate or predict. So the trick is to look at one of the first papers which actually hadn't any alarmist or alarming estimates. It was at the low end of the models. Most of the models that came afterwards were much hotter than this 1967 model. So yes, this model isn't that bad, but if it's actually right, there's nothing to fear about, because what it basically would suggest, that is, if you double CO2, all you get in 200 years or 250 years is a warming of 2 degrees, which is something that mankind can deal with, can cope with.
And it's very interesting, these climate models, because I'm amazed that they even come out anywhere near the truth, because the Earth is such a complicated system, and there are so many things in it we poorly understand. Clouds, for instance, we still don't understand whether they're negative or positively influence the climate. And although there are some decisions from time to time, there is no consensus on that. And if you look at the models, particularly over the last 20 years or so, they are way above what they should be. Now, I know people criticize people talking about land temperatures and air temperatures and say most of the energy is going into the sea. But surface temperature is a valid model output. And the greenhouse effect takes place in the atmosphere and influences the surface of the Earth first. So the surface of the Earth is a valid thing to compare. And you look at the models and they are way above what the observations are. And particularly if you look at the El Ninos, people have said that the recent very strong El Nino we've had means that we have a return now to the centre line of the average model. Well, that's wrong, because El Nino is a weather phenomenon and it's going to last a couple of years. And if you take the recent spike of the El Nino, which some people are using to rescue models, and you look at what would have been had it continued before that, you are still way below the models. And that's important because the El Nino is gone and temperatures are falling. So it can no longer really be used to rescue climate models. And I take, from looking back 50 years of climate models, I see, A, they're not working, and I see two eras. There was the era which ended about 10 years ago when we were told that the strength of the climate signal was so strong, it was emerging from the noise, and that we couldn't miss it, and that it would come on. We remember the famous quote in 2007 that over the next 3 years, temperatures would rise by 0.3 degrees, and that was the Met Office. But now we have an entirely different story. We're told now that decadal natural climate fluctuations are obscuring this signal. Yes. And we have to wait many more years for the signal to emerge. That's a completely different approach to this subject. And yet, knowing that, I find it difficult to really take seriously people saying that the models of 50 years ago were that good.
I have no hesitation to agree with your deep skepticism. On the other hand, you have to acknowledge that the model, at least the model they were referring to, the one in 1967, is a pretty good reflection of what has happened over the last 150 years. The problems, in my view, of most of the models that came afterwards are that they predicted much more warming than this 1967. Now look at what has happened since 1945, which is basically the cutoff where the IPCC says that's when the anthropogenic signal or driver of climate change really kicks in. Now, since then, we've basically emitted 3/4 of all, or even more than 3/4 of all CO2 emissions that have been emitted since industrial time. But if you look at the trend since 1945 to today, to 2017, so 72 years or so, the trend is basically a decadal trend by 0.1 degree. 0.1 degree. So if we extrapolate that into the future, then by 2100, the global temperature would be less than a degree warmer than today. So this is nothing to be concerned about. It's the claims of 3+ degree warming, which is the average kind of from 1.5 to 4.5, that makes people concerned. But the actual data shows the warming much, much slower. And people are either ignorant or simply don't know the facts or don't know the data to realize that global warming has been A, very benign, B, very slow, and hasn't accelerated. I mean, the claims of the Met Office that the pause is now over and that there is a return to the fast warming of the late 20th century simply doesn't add up. If you look at the decline in temperatures since the peak of the El Nino, the trend is actually coming fairly quickly down to where we were during the first part of the 21st century.
Yes, there are people who like drawing straight lines through everything. And people who will draw a straight line through the temperature in 1979 or 1945 and end up with what we today and say, oh, that's what it means, we can extrapolate from that. No, you shouldn't do that. You should look at the data. And actually, since the last 30, 40 years, in the 1980s, for instance, there is if you look at Hadkrut 4, Hadkrut 3, there was very little warming in the 1980s. Statistically, nothing. I remember Sir John Horton coming into my outside broadcast van when I was a BBC science correspondent, and I would ask him every year through the late 80s, has the world warmed yet? And he'd say, no, we can't say statistically it has. And it wasn't until a few years later that they were able to say, yes, it's peaking above the noise. So the 80s, no warming. The noughties, from the El Nino peak in 1998, you had 2 years of a La Nina. Then you had a stretch up to the beginning of the recent El Nino, where, frankly, the gradient is zero. And you can look at that. There are El Ninos and La Ninas in this, but the overall trend there is zero. So if you look over the past 30 years, the warming that has occurred was in the run-up to the 1998 El Nino, the mid to late 1990s.
That's right.
And isn't that fascinating that after the 98 El Nino, the temperature plateaued? And that's the question you and I often talk about as to what's going to happen in the future. Because we don't know if the temperature is going to start to go down or if it might plateau again, possibly at a higher level than it did before.
Yes. Well, it will be very, very interesting to see what the next 3 months will bring, because the Met Office, when they predicted the average global temperature for 2017, they have a range somewhere between 0.63 degrees Celsius and 0.87 degrees Celsius above the long-term average of 14 degrees Celsius. So there is a pretty good chance that this year will be at the very low end of this estimate, possibly even below the low end, depending on what the next 3 months will bring. Because basically September has brought back global temperatures to where temperatures were just before the El Nino. And so even if temperatures now remain at this level, the 2017 will be far below last year and not significantly higher than their low estimate. So I wouldn't be surprised if 2017 turns out to be much, much colder than most people expected.
And you would expect, over the past 15 years or so, 20 years or so, you would expect a gradual uplift in monthly data, in monthly temperatures. And the September this year, although months are very variable, is very similar to the Septembers of 15 years ago, which is suspicious and interesting. But of course, what people often do is they draw a straight line through all this. And therefore, the huge temperatures of the El Nino recently push that gradient up and gives you a rising gradient. That's weather. You have to take the weather out.
Yes.
And if you do that, you've got this very interesting, what they call a hiatus or a pause. Although, didn't Michael Mann in a recent tweet replying to Lamar Smith gave for me what was a hilarious nuance on the whole thing. He said, our study does not support the notion of a pause. Well, in global warming, only a temporary slowdown. Well, we've been talking for years about a pause, a hiatus, a temporary slowdown. What does it mean? That's playing with words and that's nonsense. The fact is the data shows that it's not going up linearly. Yes. There's more going on. And that's the big change in climate science, the decadal climate variations. And it's interesting that recently the decadal climate variations are suppressing the rising temperature. But in the 1990s, we had a rise in temperature, of which many people say was not due to a decadal fluctuation. So it's all very interesting if you approach this data really dispassionately, without preconceptions.
So here's the question, David. or two questions. The first question is, given that the El Nino peaked last year, why has 2017 been comparatively warm to previous El Ninos, where the El Nino warmth dissipated much faster? So there's the question, why did it take much longer to fall to where it's now been? And the second question is, how far can it go? How far down could it go?
Well, it's not surprising that El Ninos differ in their behaviour. We've only got, really, I suppose, three strong El Ninos to compare together to each other. One was in 1982, one was in 1998, and we've got the current one. So these were much stronger than other El Ninos. And the one in 1998 was a straight up, straight down, straight into a La Nina. So after this very sharp peak, you got a La Nina, which was a couple of very cold years, and then it came back up again. That hasn't happened this time. We had hints of a La Nina, but it didn't happen. So given there must be a variability in the way these things behave, it's perhaps not surprising that the heat did not dissipate and that we still have got some heat, possibly left over from it. Although it's, as with all these temperatures, it's not the whole world that's warm. Very often it's the Arctic that's getting warm, and that can make you think along different lines. So globally, yes, it's been a warm year, but it's coming down after an even warmer year of the last couple of years. So that doesn't surprise me. You have to look at these things over several years.
Of course.
We have to really let the El Nino get away from us and see what's happening after that. And I don't think we can quite do that just yet. Who knows what the future, there's a problem with science, and that's data you haven't got yet, and who knows how far down it could go. We could have a La Nina, which could bring it quite down, and then presumably it would come back up again, or it might not come back again. We just don't know. I mean, nobody knows what the temperature of the next 5 years is going to do. It could start to rise. That's the thing we have to see eventually is a long-term rise.
But next year there will be, for the first time ever, a company allowing bets on the future global temperatures.
I want to bet, didn't I?
So if you were to put 20 quid or 50 quid on the temperature in the year 2018, would it be cooler or warmer than this year?
I would say it would be cooler or warm. It'd be cooler. The mean would be cooler than this year, but the error bar would probably overlap somewhat. And in fact, I would have think now this is.
But they don't deal with error bars. I think they'll just take whatever the NOAA and Met Office announce.
Well, I'll tell you a funny story about this. A couple of years ago, I had a bet with James Annan, who's a climate scientist, about what the temperature would be in 3 or 4 years' time. And this was done by the BBC Radio 4 More or Less programme. And I won it. But actually, I didn't win it scientifically. I mean, I was true to the numbers as they were at the time. I won this. But when they wanted me to extend this over the next 5 years, I said, we've got to be a bit more scientific about this. We've got to allow for error bars. Otherwise, I'm just putting my money down and waiting for a fluctuation that takes me above more than one standard deviation above the mean. I said, and that's not winning anything. That's normal fluctuation. So the bet should be over the next 5 years, the temperature rises more than 2 standard deviations above the mean, which is a good first pass definition of a change. Wouldn't accept it. So a lot of these bets are fiddling around in the noise, and you can just be lucky. But if you look on the longer term, taking statistics into account, these bets have actually been a good thing for those who vote against long-term warming.
Yes, and I guess it might also be good for investors who want to know just how credible these predictions are. Because at the end of the day, we're talking here about the biggest international policy area that is affecting the energy markets all over the world. And if it turns out that the predictions were significantly wrong, and that many of these multi-billion, hundreds of billions of investments turn out to be based on some dodgy predictions, now that wouldn't look very good, would it?
No, it wouldn't. And speaking of bets and statistics, brings me to the other editorial in Nature Climate Change, which is called Storms Ahead. Now, this was really fascinating. It says flooding and storms account for almost 3/4 of weather-related disasters. The past month has seen flooding in Asia, powerful hurricanes in the Atlantic. These events are not caused by climate change. They've occurred throughout history. And then it changes. It says, but previous benchmarks are no longer valid. 1 in 100-year events are happening more often, and the timescales are shortening. Then it goes on to talk about Houston, which has been affected by flooding, and it said it's the third 1 in 500-year flood that the city has experienced since 1979 in the last few years. This is statistics gone mad, because overall, there are several ways to look at extreme events, but overall there is no evidence that they've changed. If you look at the data, there's no evidence at all that hurricanes have changed, apart from the SREX report from the IPCC a few years ago, which talked about extreme precipitation, which is a very technical definition, and the number of warm days. Well, we live in the warm decade, so the number of warm days is bound to go up, as it did in the medieval period. The number of warm days goes up when the temperature of the world rises. But there's no evidence that there are more hurricanes, Al Gore take note, anything like that, any extreme events, droughts, floods, heat waves. There's no evidence there is. So actually, talking about 1 in 500-year event happening more than you would expect just shows that these people don't understand statistics. They ought to go and take a course on poker playing, because what is it that detective said, Charlie Chan? He said, strange events permit themselves the luxury of occurring. This is statistics. Now, there's been an interesting move in the past few years to attribute droughts and floods and hurricanes to climate change. And they usually try and work out what the climate would have been without man. They look at the climate with man and say, what's the difference? Are there more or less? And it's very early days. There's a lot of philosophical arguments about this process, a lot of practical problems about it. And yet the results of that attribution are being bandied around as though it's certain, as though it's definite. The drought, the heat wave in Russia was very low possibility without climate change, but with climate change, we are responsible. This is far too early. I don't know what you think about this, but I think that this is where the public are being misled about statistics.
Yes. Well, my take on extreme weather events is twofold. One, if you look specifically at the observational evidence, where the observations are good, and we only have basically observations for many of these events going perhaps 100 years or a little bit more than that. And we always have the problem of, in the past, the reporting wasn't as good as it is today, and the monitoring wasn't as good. Despite that, there is simply no evidence that most of these extreme weather events are getting more extreme or more frequent. That's one fact that even the IPCC by and large acknowledges. And even today, whether it's droughts or floods, storms, hurricanes, there's no significant change. But much more importantly than that is that compared to 100 years ago, 90% less people are actually affected by these events. So we have adapted globally to extreme weather events. For instance, 100 years ago in a heat wave, tens of thousands of Americans would have been killed simply because they lived in sheds on farms, they didn't have air conditioning, they lived in cities, they were poor. Today, most people in the US and the developing world live in decent housing. They are protected from heat waves, cold snaps, and increasingly also from hurricanes. Because if you think about Bangladesh in the 70s, a tropical storm could easily kill 100, 200,000 people, and did so. Today, we have satellites. People can be warned 1-2 days in advance. They can be put up in shelters. They can be moved. So we are dealing much better with extreme weather than ever before. And the developing world is catching up as well. So people actually dying from extreme weather events have dropped by 90%.
It's a success story.
It's a successor in every respect. So extreme weather is not a big deal. It's a big deal for the insurance companies because they have to pay, and the houses have become bigger and more expensive, and more cars are destroyed, and you have to repair streets. But that's an insurance issue. So whenever you have these big disasters, the insurance industry has to pay up. They will then raise their premiums over the next 5 years and will basically get their money back. It's not a problem for any society other than poor countries.
They can be helped.
But they can be helped by A, becoming
Richer.
developed,
Yes.
and B, when disaster strikes, to help them with humanitarian help, which is also much better today than in the past.
And it's an exercise for the listener. Whenever you read an article about extreme weather that starts off dramatically, you should look for the point where the narrative turns, where it says, it's not happening now, but we think it's going to happen in the future if the models are correct.
Yeah. And it's getting worse.
And it's getting
it's
worse.
always getting
It's always
worse.
getting worse. It's not getting worse. The statistics show it's not. And until the statistics show a change, then all this is prediction based on models for the future. And at the moment, the statistics don't show that extreme weathers have changed.
One other excellent counter argument to the alarmist narrative is that despite all the extreme weather events we've experienced, and despite all the warming we've experienced, global harvests have record harvests. So agricultural production is at a peak and is getting better all the time as well through new technology. So there is really no case to be made that societies face some kind of existential threat by extreme weather events. We're dealing with extreme weather extremely well.
Now, the world is warmer than it was 150 years ago.
Absolutely.
And people, some scientists say that as the world warms, as the world has warmed, we are not equipped to deal with this climate because we grew up and we built our civilization on the climate of the past and that it's changing. Now, there was an interesting paper we saw recently at a conference by Orth et al. And it said, did European temperatures in 1540 exceed present-day records? Now, this goes right to the heart of the temperatures we're experiencing today. And we have built the Industrial Revolution on. Because there's no doubt that the Industrial Revolution came about during a cold period. And then it's got warmer since then. But there's evidence, and this paper suggests so, that if you look at the weather records of the medieval period, that a lot of people dismiss this, but there's a lot of research which shows that there were periods during that time when it was at least as warm as it was today. And people have tried to get rid of that, but it's persistent.
Yes, well, I must admit that I'm extremely skeptical of all temperature reconstructions that are not based on observations.
On a thermometer.
Yes, basically. I have no trust whatsoever in most proxies on which these reconstructions are based. So I'm totally agnostic about the medieval warm period and the little ice age. I'm less agnostic, but even there, the question is just how cold, much colder was it than today? But all these warm periods in the past, we know there was a Holocene optimum about 6,000 years ago, but again, no one really knows how warm it was. I'm totally open to the idea that it was perhaps as warm as today, but no one knows. No one knows. What we do know is that we've had warm periods, we've got cold periods. We also know that society suffered much more during cold periods, primarily because agriculture was severely affected, and during warm periods, societies thrive. There's a good paper published earlier this year in July, August by scientists of the Chinese Academy of Science that shows that in China, there were about 5 or 6 warm periods over the last 2,000 years. And it is during these warm periods that Chinese civilization thrived. Mm-hmm. And they even claim that the modern warm period is not unprecedented, and that there were at least 2 warm periods in the Middle Ages that were very similar to today. So yes, you have these papers, and then you have counter papers that look at different proxy data coming to different conclusions. So I think we have to take all these reconstructions with a large pinch of salt. We simply don't know how warm it was 500 or 1,000 or 2,000 years ago. It may have been as warm as today, it may have not, but there's no doubt that we've gone through warm and cool periods.
Sometimes I ask people what they think normally happens to planet Earth. I say, look, you've got a series of parameters: the temperature of the surface, the temperature of the atmosphere, the temperature of the oceans, the ice extent at the poles, the temperature in various parts of the world, the rainfall. How would you expect it to change? Because it's unphysical and unrealistic to expect no change. Something is going to be changing. In fact, even if the long-term climate of the Earth was stable, a lot of things would be changing. Ice would be getting larger or smaller, temperatures would be rising or falling. You cannot have a system like the Earth static in all its climate parameters. So over a period, you're going to get periods where it's going to be warm and cold. You're going to get periods where all these parameters are changing. Absolutely. In the same direction, in opposite directions. But the question is, what's happening today? And people say, well, things are happening so fast today that it's unprecedented. And it's true, we have more carbon dioxide in the atmosphere than we've ever had before. We live in a warm decade. But we're missing, I think, very frequently the background, that what normally happens to planet Earth in which to calibrate what we're seeing today. And that's these decadal climate fluctuations again. Nobody 15 years ago said, we're going to have a period where there's going to be no. Can you imagine somebody in the late 90s saying climate change is a big, big problem, but in the next 20 years or plus, the temperature's not going to change? It would have seemed awkward. But that's what's happened. And that's because there are factors at play we don't understand, and because the climate is always changing in various directions. And the big thing is to work out what's us and what's always been happening.
I think that's a very important point. There was a debate at the Cambridge Union last week where I participated. And the motion was this house would rather cool the planet than warm the economy. So basically, climate change and climate protection is more important than economic growth. But the point speakers were making is that we need to cool the planet. I mean, they literally meant we need to cool the planet because the current temperature is too hot. And I said, what is the problem with today's temperature? You know, we live in a very benign period of our planet, very benign compared to previous ages. What's the problem? And people were saying, yeah, but the problem is climate change. It's too hot. We've got all these disasters. So even the average Cambridge student thinks that every hurricane that hits America is due to man-made climate change. They can't imagine that 100, 1,000, 10,000 years ago, these hurricanes happened just as frequently or as severely as today. They really believe that when they watch telly or they read the papers, every disaster is due to us. It's a big problem because they really said we need to cool the planet. I said, by how many degrees do you want to do you want to cool the planet? Are you aware of how many people are dying every year from cold, not from the heat?
Look at what happened to Europe in the Little Ice Age, the early 1600s. It was a catastrophe. Populations were on the move. Mortality went up. Laws were passed allowing families to marry relatives that they weren't allowed to marry before because there were so few people. It was a catastrophe.
Yeah.
And that was down to the fall of less than a degree
Yeah.
in Europe. Let some of those Cambridge students wonder what it would like to have attended Cambridge in the 1600s. They would have a different view on these things, I think.